Okay, everybody. Sorry about that, the little break, but we're just talking about after a concussion, impact to the body. You know, you have the still point, you have the initial impact, you have the rapid acceleration and stretching of your cells and the brain tissues. You have the recoil, which is the counter-coup impact within the skull itself, and then you have the stop point. After you have the impact, you have the stop point, everything settles, but there is what's called this residual resonance accumulation. Your bell is rung after a concussion. And so that's the chain reaction of events that happen after an injury. And so what happens with concussion and traumatic injuries rather from sport are injury overlays. And so it's an accumulation of injuries itself. And so that's ultimately where we get these chronic progressive diseases, something like CTE, Parkinson's, ALS, Alzheimer's. These are all progressive diseases where the brain is degenerating. It's eating away at itself. And so ultimately, what we're uncovering the diseases. And so it's the purpose of these videos to help add insight on how do we address these injuries. And so in the previous video, when you have a concussion, you have acute emergency risks. You have to make sure that there's no hemorrhage. So you have to go get an MRI, you have to go maybe get a CT scan if you suspect some soft tissue damage, or some rather bone with CT, but soft tissue with the MRI. But they'll both show hemorrhage within the brain tissues. The problem with MRI and CTE is it does not pick up. It doesn't pick up CTE. It doesn't pick up chronic traumatic encephalopathy because the depth of the brain condition is so small that it's not picked up on the scan. That's why we're actually only able to verify the CTE right now upon autopsy. So after a person dies, we're able to take the brain out of the body, autopsy it, and analyze it under a microscope, which is where we see this condition, and we'll get into this in a second. So after an injury, your body is vibrating. There's hyperactivity of your nervous system, hyperactivity of brain function, electrical activity up and down your spine. Your body is in a state of fight or flight. And so upon impact, you have all of the physical traumas. You have capillary damages, you have edema, swelling, fluid accumulation, blood circulation increases, and you also have inflammation in the area of the injury site. And so again, we're seeing, if we diagnose this from a Chinese medical perspective, this is a hot, yang, internal and external condition, and it's an excessive condition. And so with these injuries, that's why we see the hyperelevation of the nervous system itself. And so let's talk about, so we have these physical traumas. Make sure that there's no hemorrhage. The long-term effects occur from the accumulation of scar tissue basically forming at these injury sites. Football players, if you at the higher levels, endure hundreds and hundreds of impacts to the head, and so that's the real danger. And so that's ultimately what we're talking about here. So you have your physical trauma, capillary damage, the edema, the blood circulation, the inflammation. CTE is diagnosed from a protein accumulation which is found within these injury sites. So what's a tau protein? So you have your nerve cell. This is a neuron. Right there. Okay. So you have the nerve cells. This is what conducts electricity within your brain. The neuron is composed of what's called a microtubule. This gives structure. This is within these small circles here. This is within the nerve cell. This is the small structures that give the nerve itself structural support, like I said. And so this is what conducts electricity. Upon impact, you have a rapid stretching and contraction of this nerve here itself, of all your cells, all of your tissues within your body, from the outside, the skin, the fascia, the connective tissues, your muscle, your skull, the dura, the brain, and the cells. Everything is stretched and brought back together. And so that includes these microtubules, which give structural support to the neuron. When this is stretched at both ends, these small circles are the proteins that hold these microtubules together. This is the disease right here. Tau proteins, which encase the microtubules. When this is stretched in either direction, these proteins are released because of the rapid stretching and brought back together. And so what happens if you have a brain, so let's see if we can draw a little brain here.